morning and thank you for joining us today. We'll start the session in a minute or two. Good morning again and thank you for your patience. Welcome to the session Navigating the AWS Database Ecosystem through Introduction, hosted by Cloud.in. I'm Suvarna Jadhav working with Cloud.in as a Strategic Partnership and Alliance Manager. For today's session, we have Ms. Rutuja as a speaker. Rutuja is working with Cloud.in as a cloud consultant. We'll delve into the heart of AWS database ecosystem, whether you're a seasoned AWS user or just starting your cloud journey. Understanding the database landscape is crucial. Our expert speaker will guide you through the intricacies, helping you make informed decisions and optimize your data architecture on AWS. All attendees are muted by default and cannot be unmuted during the session. If in case you have any questions in between the session, please ask questions through the questions section. I will request Rutuja to start the session. Over to you.
Thank you so much, Suvarna ma'am. Hi, good morning, everyone. Thank you for joining. So, as you all know, we will be we will be understanding about the databases offerings that we have from AWS Cloud. So, let us first understand the agenda that we have for today's session. So, just a minute. So, Varna, is my screen visible?
Yes, Rutuja, your screen is visible.
I guess it's not sliding away. Just allow me a minute, guys. I guess we have an internet issue.
Sure. No. Rutuja, all well? Or should I present the screen for you?
Ma'am, I guess that will work because my screen is not moving.
No. Is my screen visible?
Yes, ma'am. Thank you. Okay. Sorry for the inconvenience, everyone. Let's move ahead. So let us look at the agenda first for today. So firstly, we will be overviewing the AWS database ecosystems. What database offerings does AWS has for all of its clients and everyone. Next, we'll understand what is the importance of databases in modern applications that we have running right now. So why should we use databases? Why should we very importantly have databases in our infrastructure? Next, we'll have a deep down understanding of the relational databases on AWS, NoSQL databases on AWS, and some of the use cases. So moving on. Um, so let us now understand the overview of AWS database ecosystem. So as you all know, AWS database is a the ecosystem of AWS database is a comprehensive suite of cloud-based database services that the AWS offers. It caters to diverse the data storage and management needs of the clients. It encompasses a variety of range of database solutions, including fully managed relational database service, which actually supports the popular relational database engines such as the MySQL, PostgreSQL, and Microsoft SQL Server. Additionally, the ecosystem also includes Amazon DynamoDB, which is a fully managed NoSQL database service. We'll go through the service in detail in our upcoming slides. And also the Amazon Aurora, which is a high performance relational database, and Amazon Redshift for the data warehousing purposes. So the ecosystem is actually designed in such a way that it addresses the varying requirements of the modern applications running nowadays by providing the users with the ultimate flexibility, reliability, and the ability to scale the resources according to their demand. With it is also focusing on the security and compliance and the ease of management. The AWS database ecosystem empowers the organizations that are using these services to build and scale their applications very efficiently in cloud. So in this slide, as you can see, I have listed down some of the benefits that you can avail by using the AWS databases, and let us look into that. So firstly, you'll have to choose the right purpose-built engine database for your workload. So build your use cases driven highly scalable and distributed applications suited to your specific need. So AWS actually offers 15 plus purpose-built engines to support diverse data models, including the relational, key value, document, in-memory, graph, time series, and all the other database types that we have in the market. Next, you can also run fully managed databases in the AWS cloud. So you can actually free your teams or maybe the employees that are working on databases from the time consuming database tasks like, for example, you can say server provisioning, patching, and the backups. So AWS offers us fully managed database services where it provides you continuous monitoring, self-healing storage, and automated scaling to help you focus on the application development more and worry less about these compliances. Next benefit that you can avail is you can achieve the performance that is at scale. So you can start small and scale as your application grows with the relational databases that are like 3 to 5x faster than the popular alternatives, or non-relational databases that give you the microsecond to sub-millisecond latency. So to match your storage and compute needs easily, often with no downtime. So you can avail the performance that is at scale, and you can get the best performance for your applications if you get with the AWS databases. Also, you can rely on the high availability and security that AWS offers. So it supports multi-region, multi-primary replication, and it also provides full data oversight with multiple levels of security, including the network isolation and the end-to-end encryption that they have. Also, AWS databases deliver the high availability, reliability, and security that you need for your business critical and enterprise workloads. So such factors actually affect a lot when they are not completely managed. And if you have a team that is working on all of these parameters, it will be a bit of a tedious and difficult task for them. But with AWS managed databases, it becomes very seamless, wherein all of these are taken care by AWS itself for you. So next, we will be understanding why do you exactly need, yeah, sorry. So here, as you can see, these are the database types, relational, key value, in memory, document, etc. So there are multiple services that are offered by AWS for the specific type. So for relational, you have Amazon Aurora, Amazon RDS. Key value, you have DynamoDB. In memory, where you have to take care of caching, the session management, for example, gaming leaderboards, you have an application of gaming and everything. So you can use the Elastic Cache or the Amazon Memory DB for Redis. And for document type databases, you can use the Document DB. So there are multiple database types and there are multiple offerings by AWS for all of your database types. So moving on, let us now understand what is the need and why should you have a database in your infrastructure majorly in the modern applications that we have right now. So as you all know, databases play a very crucial role in the modern applications, serving as the backbone for data storage and retrieval and management. So here are some of the reasons that will be highlighting the importance of databases in the context of modern applications. So considering the data storage and retrieval. So databases actually provide a structured and efficient way to store and also retrieve the data that you have in your database. So they enable the applications to organize information in a format that is easily accessible and can be quickly retrieved when you need it. So if you use databases, you have a fixed format that you can align your data in. So it will not be a hassle to search for a numerous amount of data that you have. So in that fixed format, you can easily access your data and also retrieve your data. The data integrity is also a major factor. So databases enforce data integrity by by implementing constraints and the rules that ensure the accuracy and the consistency of your data. So this is particularly very important in applications where maintaining the correctness of data is very critical. So for example, when you have very critical data in your application. So integrity matters a lot for critical data. And you can avail this parameter by using databases in your applications. Next, we have the concurrency and transaction management. So nowadays, modern applications often involve multiple users accessing and modifying the data simultaneously. So databases manage the concurrency in this, and that allows multiple transactions to occur concurrently while ensuring that the data that is there remains consistent and the transactions are isolated from each other. So this majorly points out the transactional data that you have in your database. So which keeps on changing and you have high concurrency involved in that data. So also in these cases, the databases manage the concurrency and the transactions very seamlessly. Also a very important factor, scalability. So as the applications are growing, as the market is growing, the amount of data they handle also increases. Obviously, as you see nowadays, there's a lot of data that is in market. So you have to scale now and then. There's a lot of less downgrade in scalability. You have to increase your scalability now and then. So that is a lot going on. So databases provide the mechanisms of scaling, whether it is horizontally by adding more servers or vertically by upgrading the existing hardware that you have to accommodate the increased data volume and user load. So the AWS supports both types of scalabilities for your databases. Next, the query and search capabilities that a database offers. So databases also support the powerful query languages that enable applications to efficiently retrieve specific set of data. This is very crucial for the applications that need to filter, sort, and search through the large data sets that they have. So the main purpose of using a database, as much as my knowledge, is that we have to query the data and we have to search. There's a lot of searching and sorting in the data. So this becomes very seamless if you have a database in your application. So moving on, let us now look at the relational databases that AWS offers. So a relational database is usually stored in a tabular form, and the relational databases are particularly, they use a structured query language, for example, SQL, to run queries to perform operations such as the insertion, updating, and the deletion operations. So AWS offers multiple relational databases. So mainly the three majorly used in market relational databases by AWS are the Amazon RDS, Amazon Redshift, and Amazon Aurora. So let us look into Amazon RDS in a bit detail. So Amazon RDS, which is a relational database service, is completely managed relational database service that offers the choice of all the 7 popular database engines that we have. This includes MySQL, Compatible Edition, Postgres, RDS for MySQL, RDS for MariaDB, for Oracle, and the SQL Server. So this means that the code, applications, and tools that you already use today, that you have in your existing databases, can be used with the Amazon RDS. So for example, now if you have an application running already and you have a on-prem database, so you can easily migrate it to Amazon RDS with whichever engine that you have in use, because RDS is compatible with all the 7 famous engines that we have in market. So one of the key advantages of Amazon RDS is that it handles database management tasks such as the provisioning, patching, backup, recovery, failure detection, and repair. We'll look into some of the key features and benefits that we can avail using Amazon RDS. So firstly, it is very easy to set up and deploy. So you can use the Amazon Management Console, the RDS command line interface, SDKs, or simply API calls to access the capabilities of a production-ready relational database in minutes. So Amazon RDS database instances are pre-configured. So with the parameters and settings appropriate for the engine and class that you have selected, you can actually launch a database instance, and you can connect your application within minutes. So the database parameter groups provide you a granular control and fine tuning of your database to avail all of these connectivity that you can get with your application. So it is also easy to manage the database administrative tasks. So actually RDS lowers your administrative burden by managing the undifferentiated administrative tasks, such as as I said before, the software patching, backups, scheduled maintenance jobs. So Amazon RDS will make sure that all of the relational database software powering your deployment stays up to date and with the latest patches on it. So you can exert the optional control over when and if your database instance is patched. So it is completely patched with all the latest upgrades, and you don't have to worry about the downgrades if you face any. It is completely updated and managed by AWS. So although it is safer, simpler, and with the faster upgrades that AWS offers us for the blue-green deployments. So Amazon RDS blue-green deployments actually allow you to make safer, simpler, and faster database updates with zero data loss. So in a few steps, your blue-green deployments create a staging environment that mirrors the production environment, and this keeps the two environments in sync using the logical replication that we have in RDS. So you can actually make changes such as maybe there are major changes or minor version upgrades, schema modifications. This will in your staging environment, and this will not impact your production workload. So when promoting your staging environment, the blue-green deployment block writes to both the blue and the green environments until the switchover is actually complete. So the blue-green deployment use a built-in switchover guardrails that time out the promotion if it exceeds your maximum tolerable downtime. It detects the replication errors, checks the instance health, and all the other factors that are aligned with it. So also in RDS, you can choose from the multiple general purpose and provisioned IOPS SSD storage options that they provide. So Amazon RDS actually offers a choice of two different storage types. So for most use cases, general purpose storage will work for your database workload. This is an SSD backed storage option. So this delivers a consistent baseline of 3 IOPS per provisioned GB and provides the ability to burst up to 3000 IOPS above the baseline. So for workloads that require high performance, Amazon also offers them the provisioned IOPS storage. So this type of storage wherein SSD is backed with option designed to deliver faster and predictable consistent IO performance. You can specify the IOPS rate when creating a database instance. So while you create a database instance, you can actually customize the IOPS rate also over there according to your need. And RDS provisions the IOPS rate for the lifetime of your databases. So this storage type is optimized for the IO intensive transactional database workloads, and you can provision up to 256,000 IOPS per database instance, which is a very huge number. And although your actual released IOPS may vary based on your database workload, instance type, and the database engine of your choice. Also, another factor, access point in time recovery and with automated backups. So the automated backup feature of RDS is very useful actually. It enables the point in time recovery for your database instance. So if you have any loss of data and you need to recover the data, you can avail this. And Amazon RDS actually will back up your database and the transactional logs and store both for a user specified retention period. So this actually allows you to restore your database instance to any second during your retention period. In terms of security and compliance, you can protect your data with encryption at rest and encryption in transit. So Amazon RDS allows you to encrypt your databases using the keys you manage through another service provided by AWS, which is Amazon Key Management Service. So on a database instance running with RDS encryption, data stored at rest in the underlying storage is encrypted. So as its automated backups and read replicas and snapshots are also encrypted. So you also have control actions of AWS users and groups with the resource level permissions. So Amazon RDS supports several ways to authenticate the users, including uh, AWS identity and access management, and you can actually give grant permissions according to the policy, and you can grant minimal permissions to any specific users for your database, which will also protect and have security over your database. You can also power your database with the push button compute scalability. So you can actually scale the compute and memory resources, powering your deployment up or down, or up to a maximum of 128 vCPUs and 4000 GB of RAM. This is the maximum range, and the compute scaling operations typically complete in a few minutes. So this is the maximum range of vCPUs and GB of RAM that you can scale up to. You have also, a very popular advantage that we have in RDS is it provides us flexible migration options. So you can perform the homogeneous and heterogeneous migrations with the AWS DMS, which is Database Migration Service. So it is a managed migration and replication service. So for a database and analytics workloads to like perform both the homogeneous and the heterogeneous migrations. So with key features like AWS DMS Fleet Advisor and the AWS Schema Conversion, you can actually discover, plan and convert and migrate your workloads all within the AWS DMS. Also, you can assess and convert the source schema with the schema conversion tool that it offers. So yeah, these were some of the many benefits that we get if we are using the AWS RDS for your relational database work. So moving on, we have the Amazon, yeah, sorry, we have this slide. So as if you can, here you can see, for example, if you have your database workload on-prem, all of the listed down activities will have to be performed manually. And in exchange, if you have your database on an EC2 server, some of them will be performed, managed by AWS, but still, example, DB software installation, software patches, DB backups, app optimization, scaling, all of this will have to be done manually, because actually EC2 server is a compute-based service, whereas RDS is completely customized for database workloads. So we highly recommend you to have your database workloads on RDS, wherein listing all of the factors will be completely managed by AWS, covering the rack stack, server maintenance, OS installation, DB software patches up to scaling. All of this will be covered by AWS RDS and completely managed by them itself. You don't have to manually do it. So next, we will be looking into another database service that we have in AWS, which is Amazon Aurora. So Amazon Aurora is yet another relational database service that combines the speed and availability of high-end commercial databases with the simplicity and the cost effectiveness of open source databases. So Aurora is fully compatible with only two majorly database engines, that is MySQL and PostgreSQL. It allows the existing applications and tools to run without requiring any of the modifications. So let us look into some of the key features of Aurora also. So firstly to the very major advantage that we get, which is multi-availability zone deployments with the Amazon Aurora replicas. So on an instance failure, Aurora uses Amazon RDS multi-AZ technology to automate failover to one of up to 15 Aurora replicas. So you have created in any three of the availability zones. So if no Aurora replicas have been provisioned in the case of a failure, Amazon RDS will automatically attempt to create a new Aurora DB instance for you. So this is actually done whenever you occur of any failover and you are in quick need of a recovery. So to minimize any failover time by replacing the community from MySQL and Postgres drivers with the open source and drop-in compatibility, you may also use the RDS proxy to reduce the failover times and improve the availability. Next, we have fault tolerant and self-healing storage. So Aurora's database storage volume is actually segmented in 10 GB chunks, and it is replicated across 3 availability zones, with each availability zone persisting 2 copies of each read. So in Aurora, the storage volume is actually segmented, as in you can mean it is cut down into 10 GB chunks, and it is replicated across 3 availability zones, which provides you a very high availability and also is a fault tolerant approach. So Amazon Aurora Storage is completely fault tolerant, transparently handling the loss of up to 2 copies of data without affecting the database write availability, and up to 3 copies without affecting the read availability. So Amazon Aurora Storage is also self-healing. The data blocks and the disks are continuously scanned for errors and replaced automatically. So as I said, Aurora is also completely managed. So it has the self-healing storage feature, which continuously monitors and scans the errors and replaces it automatically, and whatever comes under their manageable replaces that they can make at their end, they do it. Also, you can optimize the IO costs that by using Aurora. So for workloads which have heavily analytic application. So like for example, if you have a heavy analytic application and you have IO costs are typically the largest contributor to the database cost, and IO operations are performed by the Aurora database engine against its SSD-based virtualized storage layer. So every database page, a read operation counts as one IO. So the Aurora database engine issue reads against the storage layer to actually fetch the database pages not present in the buffer cache. So each database page is 8 KB in Aurora with the Postgres SQL compatibility, and 16 KB in Aurora with the MySQL compatibility. So basically, Aurora was actually designed to eliminate the unnecessary IO operations, to reduce costs and ensure the resources are available for serving the read and write traffic. So the read IO operations are only consumed when you are pushing transaction log records to the storage layer for the purpose of making writes durable. The write IO operations are counted in 4 KB units. However, the concurrent write operations whose transaction log is less than 4 KB, these can be batched together by Aurora and the data by Aurora to like optimize IO consumption. So if you have, so they have a fixed rate, they have a fixed amount like 4 KB of units. So if your operations are, if your transaction logs are less than that amount, they'll also batch it together so that your IO is optimized and you don't have to pay more in that. So it also optimizes your cost in this case. Also, there's a new buzz in market about Aurora, that is generative AI. So Aurora actually offers capabilities to enable machine learning and generative artificial intelligence models to work with data stored in Aurora in real time and without moving the data. So with Amazon Aurora Postgres compatible edition, you can actually access the vector database capabilities to store, search, index, and query the ML embeddings. So moving on, we have a new feature come up in Amazon Aurora recently, which is zero ATL integrations. So Amazon Aurora MySQL zero ATL integration with Amazon Redshift. This actually enables the you can say near real-time analytics and the machine learning using Amazon Redshift. So on the petabytes of transactional data from Aurora MySQL, by eliminating the need for you to actually build and maintain complex data pipelines that perform the extract, transform, and load, that is the ETL operations. So the transactional data is actually automatically and continuously replicated within seconds after being written in Aurora MySQL and seamlessly made available in Amazon Redshift. So if you integrate Amazon Aurora and Amazon Redshift, you can easily have this feature available. Moving on, let us now understand the NoSQL database offerings that AWS offers us. Yeah. So yeah, over here actually I've listed down. Ma'am, you can like just move back the previous slide. Yeah. So over here I've just listed down some of the major differences. So majorly there is a confusion between RDS and Aurora. So but there are some differences that you can keep in mind while availing the right database service for your workload. So in terms of database engine support, as we all talked about, Amazon RDS actually supports 7 engines, but whereas Aurora only supports 2 engines. But the 2 engines that Aurora actually supports is they provide the best service in those 2 engines. So if your workload is completely on only those 2 engines, you can completely avail the Aurora, wherein you get high availability. Also, in terms of architecture and design, in RDS, it is similar to installing a database on EC2 with the reliable multi-AZ feature, but in Aurora, you get the fault-tolerant and reliable feature, which has the 6 copies replicated to 3 different AZs. Also, in resiliency part, RDS has the standard recovery, but wherein Aurora offers a faster recovery from the failure. In terms of storage, the storage auto scaling is maximum up to 64 GB in RDS, wherein in Aurora you can automatically scale, and the maximum amount of storage, just a minute, yeah. The maximum of storage is up to 128 GB in terms of Aurora. Also, in terms of pricing, RDS is comparatively less than Aurora, and Aurora is a bit of expensive than RDS. Moving on, we have, as we said, we'll be discussing about the NoSQL databases that AWS offers us. So the key value database that it is also called is a type of NoSQL database, and where the method of having a value attached to a key is used to store the data, meaning that the data is composed of 2 elements, which will be, one will be the key and the other will be the value. So in this type of database, the very famous DynamoDB is offered by AWS. So let us dive into that service. So Amazon DynamoDB is a serverless NoSQL database service that supports the key value and document data models. So developers can actually use the Amazon DynamoDB to build modern serverless applications that can start small and scale globally. So Amazon DynamoDB scales to support tables of virtually any size with the automated horizontal scaling, and it consistently handles more than 10 trillion requests per day. The availability, durability, and fault tolerance are built in and cannot be turned off. So all of these good features are already built in your DynamoDB service, and eliminating the need to architect your applications of these capabilities. So you don't have to manually do all of these things. DynamoDB is actually designed to run high performance internet scale applications that would overburden traditional relational databases. So with over 10 years of pioneering innovation investment, DynamoDB offers the limitless scalability with the consistent single digit millisecond performance and up to 99.999% of the availability. So there are like numerous amount of features in DynamoDB also. So let us just dive into detail about the benefits of DynamoDB. So the key value and document data models, the DynamoDB supports both key value and document type of data models. So as a NoSQL database, Amazon DynamoDB has a flexible schema. So each item can have many different attributes. A flexible schema allows you to easily adapt as your business requirements change without the burden of having to redefine the table schema as you would do in the relational databases. Next, we have the serverless that scales to zero. So with Amazon DynamoDB, there are no servers to provision, patch, or manage, and no software to install or maintain or operate. So Amazon DynamoDB does not have versions. There are no maintenance windows, and the Amazon DynamoDB also provides zero downtime maintenance. So this also, so there is also the on-demand pricing that provides you pay-as-you-go pricing scales and automatically scales the tables to adjust for the capacity and maintains performance with zero administration. So there is a lot of like a less maintenance and patching involved in DynamoDB, so which also reduces in cost for you. The read-write capacity modes, Amazon DynamoDB actually provides the capacity modes for each table, on demand and provision. So for like workloads that are less predictable, for which you are like unsure or you may not have an idea whether you will have high utilization, the on-demand capacity mode takes care of this by managing the capacity for you. And also tables using the provision capacity, wherein you know the capacity and you've set it already, require you to set read and write capacities. So the provision capacity mode is more cost effective when you are like confident and you know the figures well. You'll have the decent utilization of the provision capacity that you specify. Next feature that we have in line is the microsecond latency with the Amazon DynamoDB Accelerator. So Amazon DynamoDB Accelerator DAX is an DynamoDB compatible caching service. So this actually delivers, you can say, fast read performance for your tables at scale by enabling you to use a fully managed in-memory cache. So by using DynamoDB Accelerator, you can actually improve the read performance of your DynamoDB tables by up to like 10 times, taking the time required for reads from milliseconds to microseconds. So yeah, there is another benefit in with aligned with DynamoDB, that is DynamoDB Accelerator. Next in line, we have the feature that we have is standard infrequent access table class. So for example, for the data that is maybe infrequently accessed or not accessed very, you access it once in a month or something, you can actually use the Amazon DynamoDB standard table class, so which infrequent access table class. So this actually helps reduce your DynamoDB cost up to 60%, and the standard infrequent class tables lower the storage cost, is designed for the long-term storage of data that is infrequently accessed. So such as the application logs, maybe historical gaming data, or old social media posts, and many more data like such. So it has the same availability, durability, and performance as the other standard tables have in DynamoDB, which is by default. But you can keep them in another storage class offered by DynamoDB, which will reduce the cost also and prevail all of the advantages also. So yeah, this was about the DynamoDB NoSQL database offered by AWS. So moving on, we have the in-memory type of databases that AWS offers us. So this type of database is primarily based on the main memory for the computer data storage. and it basically is an in-memory database which keeps the whole data in the RAM, meaning that each time you access the data, you can only access the main memory and not any disk. So over here, AWS offers us a service which is called Elastic Cache, sorry, and so let us like now look into the Elastic Cache service. So Amazon Elastic Cache is also fully managed Redis and Memcached compatible service. So this actually delivers the real-time cost-optimized performance for modern applications with 99.99% of availability. So the Elastic Cache is very ideal for high-performance use cases such as the data caching, web, mobile apps, healthcare apps, finance apps, IoT, media streaming, session stores, and microservices based applications. So Amazon Elastic Cache majorly speeds up the database and application performance, scaling to hundreds of millions of operations per second with microsecond response time. Amazon Elastic Cache actually benefits include the enhanced security, reliability, and performance when compared with the other open source alternatives in this type of database type. So let us look into some of the key features of Elastic Cache also. So here it is fully managed Redis and Memcached. Uh, so in Elastic Cache, as I said, it is fully managed. We automate time-consuming managed tasks such as the software patch management, failure detection, and recovery, allowing you to pursue high-value application development. So you get a native access to the underlying in-memory database environment, making it easy to use Amazon Elastic Cache with your existing Redis and Memcache tools and applications. So you can also add a cache to your relational database. So in case of Elastic Cache, you can use the AWS Management Console for Amazon RDS and Amazon Aurora to create an Amazon Elastic Cache cluster and attach it to your relational database. So when these services are used together, Elastic Cache actually provides the applications a combination of the real-time performance of an in-memory cache with the reliability of a relational database. So here you can actually integrate the relational database with Elastic Cache to get avail of this service, wherein you can combine the real-time performance which you get with an in-memory cache and also the reliability that you get with a relational database. So Elastic Cache also is famous for the high throughput and latency that it offers. So Amazon Elastic Cache for Redis version 7.1 delivers up to 100% more throughput and 50% lower of P99 latency compared to the Elastic Cache for Redis version 7.0. So more greater the versions come, you have greater high throughput and other features. So you can actually achieve over 1 million of requests per second per node or 500 million requests per second per cluster on, for example, we can consider R7 4x large nodes. Also, Elastic Cache for Redis versions provides enhanced I/O threads that deliver significant improvements to throughput and latency at scale through multiplexing the presentation layer, offloading, and other more things. So the enhanced I/O threads are ideal for throughput-bound workloads. If you have throughput-bound workloads, you can get avail of the enhanced I/O threads feature with the multiple client connections, and it benefits scale with level of workload concurrency. It also gives us the cross-region disaster recovery with global data store. So global data store in Elastic Cache for Redis provides a fully managed, fast, and reliable secure replication across AWS regions. So with this, you can write to your Elastic Cache for Redis cluster in one region and have the data available to be read from two or other cross-region replica clusters. So this enables the low latency reads and disaster recovery across multiple AWS regions. It is unlikely in the unlikely if you have an unlikely event of regional degradation, one of the healthy cross-region replica cluster can be promoted to become the primary cluster. So in case you have any unlikely activity or maybe some issue has occurred, so you can actually use the replicated clusters as your primary cluster also. Next, we can also have encryption in place for in-transit and at-rest data in Elastic Cache. So the support, Elastic Cache, as I said, supports the encryption in transit, which enables you to encrypt all communications between the clients and your Redis or your Memcached server, as well as between the servers. So also between the servers and also between the clients and the servers. So for Redis supports encryption at rest, which allows you to encrypt your disk usage and the backups in Amazon S3. Yeah. Additionally, Elastic Cache for Redis also provides KMS integration that allows you to use your own KMS keys for encryption. There is also another feature that is data tiering. So you can use data tiering for Elastic Cache for Redis as a lower cost way to scale your clusters. So like up to hundreds of terabytes of capacity. Data tiering actually provides a price performance option for the Redis workloads that you have. You can utilize lower cost SSDs in each cluster node in addition to storing data in the memory. So this feature is actually ideal for the workloads that access up to 20% of their overall data set regularly, and for applications that can tolerate additional latency when accessing data on the SSD. So now let us look into a use case for Elastic Cache. So like for example, if you're thinking of using Elastic Cache for your database, let us look into a use case that we have for this. So for example, ma'am, can you just move to the next slide?
Sure.
Yeah, thank you. So for example, over here I've considered a gaming leaderboard. So here you can use the feature of Redis sorted sets. So Redis sorted sets move the computational complexity of leaderboards from your application to your Redis cluster. So leaderboards such as you have top 10 scorers of a game or a computationally complex. This is especially true when there is a large number of concurrent players. So like over here, I've just considered 4, but this is very useful for data sets where you have number of players, and the Redis sorted sets actually guarantee both the uniqueness and the element ordering. So using the Redis sorted sets, each time a new element is added to the sorted set and it is re-ranked in real time. So each time you add a new player in the real time, so for example, if you have 4 players and in the first round, the player 1 is at rank 1, but then in the second round, the player 1 is at rank 3. So, and you might have also added another 5th player. So the whole order will also be re-ranked in this case. So it is then added. So yeah, each time a new element is added to the sorted set, it is re-ranked in real time, and it is then added to the set in its correct numeric order. So as you can see in this example, there are 4 gamers and their scores are entered into a sorted list using the, as you can see, I've listed down the command is ZADD. So with that, you have, for example, you named down 4 players, and using this command you listed on the players, and then there's the score from high to low. So the next command, using the command again, if you add, for example, you used ZAA to update June's score. So there's a member, you can see 4 players are added. So on the third third name, there's June. So you have to update her score. So you use the command again, you update her score by overwriting the existing entry. So for example, she now for first round she's come third, for the next round she's come second. So you have to rewrite using the same command, you have to rewrite her score again. And finally, using the command ZR, you can list the players again, wherein you can see the players in order which they have won the game. And the list actually shows, as you can see, the list actually shows that June is on the second list, second number, and it has moved up to the rank. So with this, you can actually, and also if you run ZRE rank command on the leaderboard, you will actually also get, if June is in the list, as you can see, she is in the list, so we get 1 as the return value. So yeah, so she's there in the list, and the score of June is also upgraded from first list to the second list. So like this, you can actually use the Redis sorted sets feature that we get with Elastic Caching for workloads if you have a gaming platform, a gaming application running. So yeah, here we actually come to an end with our session. I hope you have got deep insights of the AWS databases that the AWS offers us with multiple database types that we have in market. Thank you so much.
Thanks, Rutuja, for such a wonderful session. I hope all our attendees have found it useful. If anyone is having any questions, you can type in the questions box. You can raise your hand and I will unmute you. I'll just stop sharing my screen to check the questions. There are no questions, Rutuja. So I hope we can conclude the session.
Yes, ma'am, we can conclude it.
There is one question from Mohammed. What is the latency for the Aurora? Can we take this up, or would you prefer to answer by email?
Hello, ma'am, could you just repeat the question?
What is the latency of Aurora for failover scenarios and fungible data sets?
Okay, so the exact figure I might not be able to give you, but as we know, Aurora offers the low latency feature because we have it replicated along different regions. So yeah, as compared to other databases, Aurora has much low latency feature.
Thanks, Rutuja.
Thank you, ma'am.
There are no further questions, so let's conclude the session. Thank you all.
Sure.
Thanks for joining. Have a great day. Thank you.
Thank you.